Hello everyone, my name is Muhammad Asfar Jamal and I'm a student here at Bilkent University. In today's video, I will be presenting you all with my term project for the Digital Logic Design course. For my project, I have made a smart parking system with an automated boom barrier. Now, this system has a lot of real-world applications as automated boom barriers are used in various real-world applications such as parking lots and toll plazas and express highway lanes. So let's dive into the project and I will show you how it exactly works and what are the components I'm using and what is the logic behind the entire system. So here is my project setup and all the components that I am using in my project. Mainly I have the FPGA board, which is being used to control the ultrasonic sensor and the RC servo motor. I'm also utilizing the 7-segment display of the FPGA board to show the distance which I'm calculating by using the ultrasonic sensor. Here is the ultrasonic sensor. Then I also have the LCD display, which I'm using to show the available car parking slots and also the fare of each car upon exit. Then I'm using the RFID, which is connected to Arduino Uno. And lastly, I am also using the another sensor, which is the RC servo motor, which is acting as the boom barriers uh, of the car parking system. And I have also implemented a small VGA aspect of this system to show the status of the car detection and the barrier, whether it is open or closed. So now let's get more into detail as to how the entire progress of the car parking system is working. So now let me show you the entire workflow of the system. Right now the system is in its idle condition, as we can see from the dashboard, that no car is being detected by the system and that barrier is also closed. So initially you can see that the distance which is being calculated by the ultrasonic sensor is 10, which is being shown on the FPGA board. When it's more than 10, more than 5 centimeters, uh, the RFID does not do anything, it does not detect anything, it's not in read mode currently. However, when a car comes within 5 centimeters of the ultrasonic sensor, then I'm using a signal which is I'm generating from the FPGA board and sending it to over to the Arduino and converting the and I'm setting the RFID to read mode. So now if the RFID is detected, you will notice that the RC servo motor will rotate by 90 degrees. So let's have a look. As you can see, it is in 90 degrees. It stays in this position for 2 seconds and then it moves back into its initial state. You can also notice that the total number of slots has now decremented from 5 to 4. And uh, upon exit of this particular RFID, this particular car, the slots will increment by 1. So let's have a look. So it is showing the fare. I have set the fare to $1 per minute since a minute hadn't passed right now, so that's why it's showing 0. And you can also see that the slots have increased back to 0, back to 5, sorry. This also have a potentiometer which is being used to control the contrast of the LCD display. We can see it in practice. Yeah, and let's also have a look at the VGA aspect of the code. So right now, as you can see, this I'm using as my car. So right now it is at 9 centimeters from 9-10 centimeters approximately from the ultrasonic sensor. So it is showing that the status of car is false, meaning it hasn't been detected. As soon as I move it to within 5 centimeters, you can now see that it's showing up as true. This also means that now my RFID reader is in read mode, and if I use my RFID tag now, you will notice that the barrier status will also go to open. So 1, 2, 3. So the barrier status has also gone to open. It stays in that position for 2 seconds and then it goes back to closed. And I'm removing my car away now, so the status of the car detection has also gone to false. So that was my project. Thank you all for listening, and I hope that you like the project.